The Unmeasurable Diagonal, a story of Pythagoras. In the bustling market of Samos, where the Mediterranean sun warmed the marble streets, a young man named Pythagoras sought not gold or olive oil, but silence. The world, he felt, was a clamor of disparate noises, a broken string. He saw the tides, the stars, the seasons, and was convinced that behind the chaos lay a hidden, elegant pattern. He yearned to grasp the thread that wove the universe together. His search took him east to the silent temples of Egypt, where the ropes measured the rising Nile, and to Babylon, where skygazers charted the moon. Slowly, the pattern revealed itself, not in the sounds, but in the count. Every observation, from the fall of a grain of sand to the orbit of a planet, seemed to possess a numerical soul. He realized, all things are numbers. In Croton, he founded a community of seekers, the Mathematikoi, who lived by silent contemplation and shared discovery. Among them was Hippasus, a keen but skeptical young mind who always asked, "But why must it be so, master?" Pythagoras, seated before his students, replied, "To hear the world's song, you must first learn its measure." One day, passing a blacksmith's forge, Pythagoras noticed the beautiful difference in the tones produced by striking anvils of different sizes. Back in his workshop, he stretched a single string over a resonating box, a monochord, and began to divide it. A string divided exactly in half, 2-to-1, sounded the octave. Divided by 2/3, 3-to-2, the perfect fifth. The language of harmony was arithmetic. From the monochord, his gaze swept to the stars. If a string could sing by ratio, then the distance between the planets must also sing. The planets, rolling in their orbits, created an inaudible sublime music, the Musica Universalis. It was a system of cosmic purity, where every element was rationally connected, whole number to whole number. This same purity extended to the earth itself. In any right-angled triangle, he declared, a profound and simple truth existed. He demonstrated how the square built on the longest side was perfectly equal to the squares built on the two shorter sides. It was a geometric song of three voices, always in perfect, measurable proportion. Yet it was this geometric certainty that one day troubled the quiet mind of Hippasus. "Master," he whispered, standing over a large square drawn in the dirt, "if we take the side of the square to be 1, what is the measure of the diagonal?" He was trying to find a whole number ratio between the side and the diagonal, a fractional measure that could perfectly express the length. Day after day, Hippasus struggled, multiplying, dividing, seeking the clean fraction that must exist. He found none. He brought the numbers to Pythagoras, side and diagonal, and showed his work. It was a number that continued forever, a ratio that refused to be neat, a number that was irrational. It could not be sung. The discovery was a tear in the perfect fabric of their world. A secret truth, that there were numbers outside the perfect clean ratio. Numbers that defied the fundamental law of all things are numbers. The cosmos, it seemed, held mysteries that the mind could not perfectly contain. The Brotherhood debated, should this radical imperfection, this beautiful troubling truth, be hidden? The truth, however, is a river. It cannot be contained. Whether whispered or silenced, the square root of 2, the measure of the unmeasurable diagonal, endured. Pythagoras' great work was not merely the ratios he found, but the courage to seek the pattern, even when the pattern led to a beautiful, terrifying mystery. The silence he once sought had been replaced by a harmony so complex, it included the unknown. The search continues.